It does give me great pleasure to introduce Denise Goldsworthy to you. Denise was appointed as Chief Commercial Officer, Autonomous Haul Trucks in Rio Tinto just last year, September 2012. In this role, she is responsible for leading the negotiation of a multi-billion-dollar long-term commercial arrangement between Rio Tinto, Komatsu and other suppliers for the supply of autonomous haul trucks systems globally. And this is a key part of Rio Tinto's Mine of the Future strategy. And prior to Denise's talk, we'll have a very short video about Rio's Mine of the Future strategy. Prior to this role, Denise was Managing Director of Dampier Salt Limited and HIsmelt Corporation. As Managing Director of DSL, the world's leading exporter of solar salt, she achieved record earnings of US $129 million in 2009. In her role as Managing Director of HIsmelt, Denise was responsible for marketing HIsmelt iron marking technology, including securing agreements for construction of new HIsmelt plants in China and India. She attributes her success, and one of the reasons why she's here today, is to her style of leading and motivating her management team. And I look forward to hearing more about that throughout her talk. But more than that, Denise also has been with Rio Tinto for 14 years and has held a number of senior positions with industrial minerals and iron ore product groups. Prior to her career with Rio, Denise spent 17 years with BHP Steel working in a number of areas, including sinter plant, blast furnace and steel making at the Newcastle Steelworks. Denise holds a metallurgy honours degree and a university medal from the University of Newcastle in New South Wales, and is a fellow AIM and a member of the Australian Institute of Company Directors. She's also the inaugural trustee for the Navy Clearance Divers Trust, a perpetual not-for-profit trust that provides relief to current and former members of the Royal Australian Navy Clearance Diving Branch and their dependents. Among Denise's other honours is being named the 2010 Telstra Australian Businesswoman of the Year, and she has been inducted into the Western Australian Women's Hall of Fame. Denise is also an active member of the Western Australian Institute of Taekwondo, achieving the rank of first Dan Black Belt. Congratulations. Most definitely. So it's with great pleasure, we'll first look at the video from Rio Tinto, if we may, which will take about 7 to 8 minutes, and then I'll hand the floor over to you, Denise. Welcome. Thank you very much for coming today.
Rio Tinto is one of the world's largest mining companies and has operations on 6 continents. Our business is to find, mine and recover the Earth's valuable mineral resources. We produce metal and mineral products that are in high demand in modern societies, and we need to develop even more innovative approaches to satisfy this demand into the future. At Rio Tinto, we recognise that long-term sustainability is critical in everything we do. We aim to meet the challenge by developing and implementing step-change technologies with the world's best researchers and suppliers. We engage in long-term partnerships that enable all parties to benefit from the sharing of experience and knowledge and elevate our position as an innovation leader. Introducing the Mine of the Future. This breakthrough program is designed to turn traditional mining on its head by creating mining operations that result in greater energy efficiency, lower production costs, improved safety and environmental performance, and new career options for our people. We are developing a highly sensitive airborne gravity measurement system to detect subtle density differences in the Earth's crust. As high-quality ore bodies become harder to find, the new system will confer competitive advantage to Rio Tinto in a key area of mineral exploration. Combining depth mapping technology currently used in oil and gas discovery with the latest in wave field tomography to map deep mineral deposits in 3D, make it possible to predict fragmentation behaviour and improve mining methods. Our research will fundamentally change the world of underground mining. With our partners, we are developing automated tunnelling machines that can increase the rate of mining many times over. Using concepts successfully used for building the Derby to Calais tunnel, underground mine development rates can be slashed. Back on the surface, our remote mining locations will be automated and supported by highly trained staff. Driverless trucks will haul their own loads. Drilling rigs with sophisticated automated robotic systems will be remotely operated. Autonomous sensing equipment will fine-tune the ever-varying stream of ore to maximise recovery, using less energy, water and time. Remotely operated trains, train loadouts, remote rock breakers, and remote service assistants can be operated by highly trained staff thousands of kilometres away at control centres in major capital cities. This is not science fiction. Our operations centre in Perth in Western Australia is already coordinating and optimising a number of mining operations across the vast Pilbara region. And we are actively piloting technology that will allow us to operate ship loaders in the safety of the shore. High-grade ores are becoming more difficult to find and extract. We are developing advanced sorting machines capable of upgrading low-grade ores and significantly extending mine life. Imagine the sorting of a range of ore types on a truly massive scale, dramatically improving recovery from lower-grade ores. We're even applying computer modelling to the physics of flotation, helping better understand how foams behave, and ways to manipulate froth to achieve maximum mineral recovery with less wastage. And our quest for innovation doesn't end there. Rio Tinto is focused on step-change advancements to combat climate change, like new technologies to reduce the energy needed to mine, recover and deliver precious minerals and metals. It all adds up to a prosperous future for both our industry and the environment. Our pursuit of growth, sustainability and innovation plays a big part of what it means to be Rio Tinto. And with our ongoing innovation programs aimed at creating safer, more efficient and intelligent mines, we believe that the mine of the future is already here. It's just getting better. With the surge in global demand for resources comes a strong need to rethink our industry. We plan to work together with our key partners and turn our visions into reality as quickly as possible. Innovation and sustainability are the driving force behind what we do and where we want to be. Imagine the possibilities.
Good afternoon, everyone. Firstly, I'd also like to pay my respect to the traditional owners of the land on which we meet, the Noongar people, and pay my respect to their elders both past and present. So today I want to do something a bit different. You've now seen the sexy propaganda video about our Mine of the Future program. But instead of going through a fancy PowerPoint slide with 2x2 matrices that provide the meaning of life, the universe and everything, what I want to do is take a lesson from our traditional owners and tell you a story that I hope makes you all think. So let's start with a fundamental question. Why do we need innovation? My hypothesis is that if businesses and individuals don't innovate, they die. In the case of cavemen, this was literally true. However, I believe that with the increasing rate of change, it should also be considered to be true for many businesses. We have our own equivalent of the Ice Age, with the uncertainties of climate change, and while we may not have Tyrannosaurus rexes running up and down the terrace, I'm sure that during the GFC there were a few stories of nasty dinosaurs wiping out unsuspecting businesses. Sustainable transformation is a vision that industries strive for and few achieve, especially in industries as old as mining. Achieving such change combines two core skills, leadership and risk management, with the technical innovation of researchers and entrepreneurs. From my personal experience, it is not possible to get to a senior role such as managing director of a business without being successful at creating and managing innovation. Whether it is trying to market HIsmelt to the world during a global recession, transforming the safety and profitability of a business like Salt, introducing a new technology like autonomous haul trucks that I'll refer to as AHS throughout the remainder of the talk, or responding to changes in legislation, innovation and change have been a continuous aspect of my career. The Rio Tinto iron ore story is also one of continuous change. The Pilbara operation has expanded over 50 years from a single mine at Tom Price that produced about 5 million tonnes to one that operates 14 mines across the Pilbara, feeding 3 port terminals. These mines are linked by more than 1,500 kilometres of rail and operate as a fully integrated system which runs like clockwork 24 hours a day and 365 days a year. Major step change initiatives require innovation, and sometimes major innovation takes time. The two key projects of AHS and HIsmelt are part of the reinvention process of Rio Tinto. AHS will allow us to achieve step changes in a number of production performance areas, while HIsmelt will achieve step changes in the quality of saleable ore, both adding significant flexibility to the iron ore business model. The most important tool for managing change is risk management, which can be used either formally or informally. We have used change management processes along every step of the way in developing AHS and HIsmelt. However, to use change management effectively, you need to think beyond the negative aspects of risk and consider both the positives and the negatives. Think, what can go wrong and how will I deal with it? What are the opportunities provided by this change and how can I leverage them? Consider an externally imposed change forced on a business by changing circumstances. Weather events, which seem to be happening more frequently, market forces, equally happening more frequently, changing legislation, etc., etc. In terms of these imposed changes, I would suggest that successful businesses prepare to mitigate any downside. However, they put most of their effort and focus on finding the opportunities. They chase questions like, how can we respond in a way that allows us to differentiate ourselves from our competitors with both tangible and reputational actions? How can we reprioritise our investments to leverage the change? What new business opportunities will this change create? What impact will this have on our customers? And how can we provide them with solutions before they are even aware that they need them? And how can we learn from this change so that next time we are less exposed? But not all change is imposed externally. As I said before, a sustainable business must be driving internal change as well. So back to the Rio Tinto innovation case examples. Rio Tinto aims to be the global leaders in fully integrated, automated mining operations. We have a variety of businesses exploiting a variety of resources and operate in more than 50 countries worldwide. So achieving change at a global level is a huge challenge. Change must also be balanced with the need to standardise work practices as an imperative to achieve safety and other business objectives. Achieving this balance at a global level, when you consider different cultures as well as different political and regulatory regimes that often have vastly differing requirements, just increases the size of this challenge. So specifically to AHS, people have asked me, why has my role been created so recently when we already have these trucks running around the Pilbara? With no disrespect to the incredibly clever engineers involved in inventing the technologies, the answer is that finding a technical innovation and making it technically work is actually the easy bit. Turning that technical innovation into a successful business strategy requires a lot more work. At the heart of the change of AHS for both Rio Tinto and our suppliers is a fundamental tension. We are installing and operating software and hardware with half-lives of between 6 and 36 months on trucks that could have a life of 20 years. There is also the tension that arises from the traditional customer-supplier relationship. The customer tenders for a product, the supplier suggests an off-the-shelf response, a decision is made, and then they don't talk to each other until the next tender is due in 2 to 5 years' time. With tensions such as these, changes to processes, relationships and culture are required to achieve a sustainable innovation or transformational change. But let me go back a step, and that is, how do you start with a process to find a useful innovation? To do this, the key question is how to link a problem to a solution. I believe there are 2 ways of approaching this question in order to arrive at an answer. Let's call them the theoretical and the practical approach. The theoretical or solution-driven approach involves researchers, academics, thinkers, inventors and the like, who come up with ideas and solutions, often before they are even aware that there is a problem. The practical or problem-driven approach has a community, business, individual or collective with a problem, whether it's existing or developing, that then requires a different approach to find a solution. Working from only one direction relies on almost random chance for a priority problem and a solution to actually connect. With only a finite amount of resources contributing to innovation, whether it is measured in either dollars or brain power, relying on random chance is actually wasteful. Successful management of innovation in our rapidly changing world therefore needs a collaborative approach. Thinkers and potential end users need to be brought into the same room to explore the potential from both directions. In the case of AHS, Rio Tinto was seeing the problems without access to an easy solution. Autonomous haul trucks arose out of a concern about improving worker safety and reducing process variability. In particular, reducing the risks from heavy and light vehicle interactions, fatigue and variable driver performance. So in this case, Rio Tinto knew a problem existed, but it didn't have a practical solution. So how did we fix it? We searched for those working on the solutions and supported Komatsu to accelerate their development of software that had stalled in isolation of a mining partner. We now have our Yandy fleet, a fleet of 10 and 320 off-highway trucks operated without drivers, and more are on the way for the Mouldy and Hope Downs. In fact, we're in the middle of commissioning a fleet of 26 trucks at the Mouldy this week, so the numbers are starting to significantly increase. Artificial intelligence systems learn the layout of the mines, how to recognise and avoid other vehicles and obstacles, and how to ferry loads rapidly and efficiently from loading face to the crusher or waste dump with the least wear and tear, delay and use of fuel. The trucks are controlled by radars, lasers, high-precision GPS, obstacle detection systems and wireless network communications. So we've therefore reached the point of a technically viable solution. The challenge now is to move away from being engineers working out how to get the widgets to work, to business entrepreneurs who change the way we work together as customer and supplier. For this technology to grow, for it to deliver all the value that the engineers and operators have dreamed about, we must work hand in hand to turn these technical wonders into sustainable business processes. However, these processes cannot be bureaucratic and slow. They need to reflect the need for flexibility, to reflect the rapidly changing technology age, to allow the innovative thinking to continue to grow and yet be captured in the new way of working. Let's move on to HIsmelt as another example. HIsmelt is short for high intensity smelting and is the world's first commercial direct smelting process for making molten iron straight from the ore. Fine iron ores and non-coking coals are injected directly into a molten iron bath, contained within a smelt reduction vessel to produce high quality molten pig iron. HIsmelt technology brings many advantages to the steelmaking industry, such as lower operating costs, lower capital intensity, lower environmental impact, and greater raw material and operational flexibility. Step changes in iron and steelmaking technology have only come about roughly every 100 years. The steel industry was aware of lots of growing problems: limited availability of direct shipping ore and coking coal, increasing costs of energy, increasing environmental legislation, and increasing competition for land. Equally, the mining industry was aware that there are only so many Tier 1 deposits of high-grade ore in the world. Therefore, redefining what quality constitutes a Tier 1 deposit is also important to the mining industry. By combining a range of stakeholders, combining the knowledge of experienced iron and steel makers and mining companies, combining a theoretical approach based on pure kinetics and thermodynamics with practical solutions, the individual pieces of the puzzle started to be identified. And while it took several different designs over many years and required different partners at different points in the process, you can get lost in the impressiveness of the engineering and lose sight of where creativity actually became critical to the survival of this project. The GFC led to the decision to move the Kwinana HIsmelt production facility to care and maintenance. As the only operating plant, this could have triggered the end of the technology. However, this is when the small remaining team became really innovative. There were a few outstanding technical questions that needed to be answered, and the distraction of trying to keep the operating plant running safely had not given them enough time to stop and find the solutions. The care and maintenance decision had to be seen as a window of opportunity. The innovation was then how to find the answers with no plant, no people, and no money. And they came up with Robbie the robot. Robbie is a small-scale water model in that he's about 6 foot tall, which for a processing plant is pretty small scale. And the plant was built by the maintenance team in between their normal tasks, using only hundreds of dollars. Now, Robbie allowed us to see what was going on inside the process that was normally contained inside the black box. We found some answers, and interestingly, we actually found some more questions, all of which has driven a process that's allowed us to convince others that it's time to start building HIsmelt plants. In the next few years, Robbie now has a new purpose. Robbie's actually going to be used to teach operators in China and India how to run their new HIsmelt plants. So what are the lessons in their story? Don't argue with Japanese truck providers. That's the first lesson. It will go away. Firstly, neither the theoretical nor practical approach to innovation could achieve results on its own. It is the interactive space where they meet that creates the energy for a step change in development and provides the basis for progress. Neither side knows what it doesn't know. Both sides need to interact with each other in order to provoke ideas, develop systems, or apply technology to any given situation. Secondly, success in innovation takes leadership. True leaders are the source of the vision. They create the energy and motivation, they facilitate the connections and conversations, and they create a safe, risk-managed environment in which to operate. They create the culture of open communication to trigger ideas, and then promote collaboration to sustain the change. If there's a moral to my story, let us rethink the heroes of the caveman era. With apologies to any historians in the room, because I'm sure there's got to be some on this campus. My twist to history. Many people talk about the innovator who discovered fire. However, who talk about the many that then learned how to use fire for the benefit of all without burning the family treehouse down? And then, even more importantly, who talks about the innovator who decided to be a good risk and scenario manager, who monitored the weather, collected seeds, then promoted their growth and fed the masses. Think of innovative ideas as the seeds. Your job as a leader, as an innovator, is to become the ultimate farmer, who can propagate, promote and feed the industry and ultimately Western Australian and Australian communities with the resulting rewards. So thank you.
Denise has opened the floor for questions. I would like to ask anyone if they have a question for Denise. While you are thinking, I would like to ask you then, just some of the nuts and bolts of your management team. So how often, for example, you mentioned then that being a leader is about inspiring, motivating, informing. How do you deal with that on a day-to-day basis with your team?
I think the key thing to a successful team, and people talk about it without really understanding what it means, and that key word is diversity. I've got a 6-person team reporting to me at the moment, which includes Japanese negotiation professionals, lawyers, technical people, business analysts, a range of specialists. And for us to be able to get the change that we need to be able to trust each other. That frequently we'll be sitting in a meeting and somebody will be using jargon that nobody else in the room understands. And they'd never met each other before. The first time a lot of them had actually physically met each other was when they were sitting across the table from Komatsu a couple of months ago. And being able to create an environment and select the right people who can actually work in that sort of situation to create something new, because that's essentially what we've had to do. And that sort of lesson applies to any role of leadership. The sorts of stuff I was doing with safety at TMP Salt, being able to change what we're doing with HIsmelt. Being able to respect the pieces, respect the individuals, because no individual can solve the size of the problems that we're trying to tackle, either as business leaders or as innovators. It's the only way we're actually going to be able to get good solutions. So I sort of roundabout answer to your question.
Yes, for sure.
I
really like the idea then of making opportunity out of what others may see as a problem, a failure, the closing of the Cowan HIsmelt. And I like the idea that you said, well, okay, we've had to close it, but we'll use that downtime now. And you came up with Robbie the robot. And it would seem to me that has gone on to bigger and better things, you said, in China and India.
Yep.
It must take a lot of resilience and also a lot of bravery, though, to go to your boss and say, well, actually, I know it's closed, but now we want to do this.
Yeah, managing emotional energy. People talk about self-management, and a lot of people think self-management is things like time management and how you manage your emails and all this sort of stuff. But I found that when you've got really big challenges, the more important piece of self-management is actually around being able to manage your own energy levels. There are sometimes your team needs you. And the HIsmelt example, morale was shocking. They'd just seen 150 odd of their colleagues walk out the door. It's sort of, why should we care? All of these sorts of things. So they had to have a source of energy. Content's one thing in terms of a vision, but you've got to have energy there as well. But of course, once you've been running it for a while, you can't keep doing it personally. It actually becomes personally very draining. So you also need to be able to be open with your team when you've got a collective big challenge about, I'm exhausted. Can you actually take the reins of keeping the energy and the morale going? And in the case of HIsmelt, I would share it around the general manager and some of the managers down there. That we would sort of take it in turns. One or other would be up and down, and these sorts of things to keep stuff going, because these sorts of things do take time. It does take resilience, and at the heart of that is actually being able to manage yourself.
That's excellent. Thank you so much. And it comes back to what you said as well about trust amongst the team members. You couldn't have done it if you didn't trust them and they didn't trust you as well.
Correct.
I do agree with you. There were some
I was going to use the HIsmelt example. obviously Rio has problems down at BHP, in particular, a lot of problems at Edith, a couple of safety deaths, I understand. So, you know, really hard to pick up projects like that and keep going. It was the same question that Margaret said, you know. Is BHP, is there any competitors in this area, Denise? Did they pick up after their problems at Edith? Or?
There's a couple of other processes around the place, and they all essentially got to the same place that Cowan did, that one plant would run that was controlled primarily by the innovator. But they weren't able to actually convince the industry to move forward. And the steel industry is really global, and one of the things that I've seen with a lot of the players that are actually involved with the technology is all sorts of biases come into play around how the technology should be used, about culturally how it should be dealt with, about the politics, who shares in value. You know, there are just so many excuses companies can actually come up with to get in the way of not allowing these things to progress. And our step into China, a lot of companies said we were mad. China has a reputation for reverse engineering and breaking every patent in, you know, just about every industry that's ever been created. So, you know, the general reaction to us going into China was you're mad, especially for the first plant, because you might get a bit of royalties and payback on the first plant, but after that, you know, the Chinese will have their own version and go off and do things. We were convinced that we had stuff to learn from the Chinese, and watching them now build the plant, we've got our own little email type community, get daily photos of what they're building up there. I'm still on the list. I've got it in the blood, can't get rid of it. Yeah, we respected them going in, and we were open in the conversations with them about negotiating terms, that this was a concern, and intellectual property in all of these discussions has been a very critical issue. But being able to sort that out, you can't lose sight of what is the ultimate goal, what is the value you're trying to create. If you get so caught up in arguing over some of the little bits and get caught in the detail, and that's part of what had happened down at Cowan as well, that people got caught up in the day-to-day detail, they actually lost sight of the vision. And when they lost sight of the vision, they actually lost energy, they lost sight of how to actually create a path of stepping forward. And going back to a small team allowed us to actually be able to find that. So when we're taking steps forward that others still may do, but we've all got a way to go.
Trish, please. Thank you for that really nice talk, Denise. That was inspirational. And when you were dealing with the new projects with the haul trucks, was there a lot of things that you had to deal with in terms of HR and management of the staff in introducing that, in the fact that you are replacing, you're having autonomous vehicles where they were once being driven by people? Is that a huge issue for you?
One of the general processes that Rio does pretty well is when we do major changes involving people. And because we didn't know what we didn't know, they did engage the people with the initial trial back in 2009 out of Los Angeles. And we had everybody involved, from maintainers to the truck drivers, to work out what needed to happen. And by respecting their contribution, we've been able to come up with a better solution. You'll hear exactly the same answers, no matter what the question is. Yeah. The same sort of processes work when you are trying to make major change. And you can now go and interview anybody that's been exposed to it, and they will make the black and white statement that it is safer being in an autonomous pit than being in a pit with unpredictable humans. Because they know what it's like when you've got a baby crying at 2 o'clock in the morning and somebody can't sleep, or they just had a fight with a wife and they're not thinking of all those other sorts of things. They know how unpredictable humans are. And we've now got the trust around the trucks that they're very comfortable. We're fortunate to be in an environment that IMO is expanding enough that nobody's losing their jobs. So it's just a matter of them changing jobs, and in a lot of cases they are getting opportunities to be trained in stuff that they otherwise wouldn't have got. So it's working out as a win-win-win all around. The HR issues definitely would have been different if we were in a product or a mine that was shrinking, and this was the only way of keeping the mine going. A lot of people were being made redundant at the time, but fortunately that's not the situation we're in.
Thank you. And I've got some more questions here as well. And I would like everyone to sort of think about this. I invite you. Denise is a wonderful mine of information here, Mark. But seriously, this is perhaps one of the few opportunities you'll have to actually ask some of those nitty-gritty questions of someone who's really open and honest and prepared to give you the real deal question, the real deal answer, I should say. Did you have a question, Michelle?
Hi, thank you. It was great to hear you talk about the importance of collaboration and the role that academic researchers have in the innovation process, and I think universities obviously have a critical role in the innovation system in this country, and I just don't know that that's recognised. And how can we do better at that engagement and working with industry, etc.?
Putting an old damp yourself hat on, going back a couple of years, we were looking at a cheaper way, quite frankly, of trying to be able to solve problems the way we were traditionally doing it. The traditional way had been go and find some expensive consultants somewhere around. And we thought, no, there's a lot of other smart people in the universities, and we can come up with win-win relationships in terms of being able to especially work with the better students, the PhD students and these sorts of things, to actually promote our reputation as an employer as well. So we went out and spoke to the universities in Western Australia. We have a partnership with ECU around trying to understand some of our environmental issues on our salt ponds, and you can guess environmental issues around salt ponds is a very important factor. But one of the things that we found in going through that process was that it's actually not easy. The bureaucracy in the universities is really, really scary for the speed that companies want to run at. You go in and say, I want to go and sponsor half a dozen PhD students. Well, you need to give us your idea about 9 months in advance, then we'll go through a selection process, and when they actually start, you won't get your results in about 6 years. That's the sort of standard response that we got, and that doesn't actually work with business. The whole idea about flexibility and speed, businesses needing to become faster. The processes around how to engage with universities to be able to get these sorts of relationships and partnerships to actually deliver something need to become faster as well. Now, I don't know how that fits in with the general academic requirements of how to get the right students and make sure everything ticks all the right boxes so that people get the right pieces of paper at the end. I don't know how that works, but there's got to be some way of being able to deal with this, because at the moment bureaucracy is scaring off industry.
That's a worry, thank you. That's a great insight to have, actually. Before I come back to it, may I just mention Pierre Horwitz is the scientist who's doing the work on birds up and down here, salt. Thank you. The Vice Chancellor did have a question over here as well, if I may.
Well, I don't have a question.
Oh.
All I did was wave.
When the VC waves, you can pay attention to this.
Denise, thank you very much for being here, because you are an extraordinarily busy person, and you've got important messages for us which I would like to capture if I can. I've just come from a selection panel we've been interviewing around the world for a relatively senior position, head of school. It was quite amazing to me that a member of the panel, well credentialed, said, when asking questions, look, I'm sorry, even apologised, said, sorry, I'm not an academic. Now, the person didn't mean that they were really superior to all of the senior academics on this panel. They were meaning that somehow they were inferior. And I did talk to them about not saying that, it's not helpful. So universities are about ideas. And it's not as though only academics have ideas. Everyone has ideas. Our DVC research actually talks about research being everyone's business. See, the brilliance of what you have put to us is that sometimes you confront problems which won't be solved through theory. They won't be solved through straight practical application. You've got to bring them together, have some turbulence. And I think in universities we've been too slow around the world to recognise that we do far better if we value the ideas of all, rather than somehow valuing more ideas from academics rather than from professional and general staff. So that is the point, that really useful message, I think, for all of us here can take home, one of the many messages?
I think there's another bit that links in with that and the speed thing that I was just talking about a minute ago. And that is that academics generally are purists. They want to find the perfect answer to the question. And if it takes them their entire careers to find the perfect answer, that's fine. The likes of 80-20 or the idea of 60-40, you mention that sort of thing to somebody in a university, it's no, it won't work. But you've got to get all the pieces come together in the right order. I'll go back to HIsmelt. Part of the problem with HIsmelt as to where it was, and I'm assuming I'm talking to people that understand some of the basic sciences here, is that the predominant expertise in the technologies that was down there was around thermodynamics, which is fine if you've got a steady state process. The piece that I brought to the puzzle in terms of my personal background, leadership and stuff aside, was my still-making experience and still-making is all about kinetics. Our kinetics in our black box, you can go and do 35 million mathematical models, and they had spent millions of dollars on mathematical models to try and understand what was going on in the black box. But they needed somebody with some practical experience. And when the idea of Robbie the robot came up, it was sort of, yeah, that's a no-brainer. Why didn't you build this 20 years ago? I did a water model for still-making processes, part of my honours in university. So it was sort of, yeah, this is standard for a kinetic process. You need to be doing this. And the questions and answers just started to flow. But they were trying to find the perfect answer in one domain. And unless you actually bring all of the other pieces in and accept, look, 60% on that one's good enough until we bring that one up, and then bring another one up, and it introduces more questions, that by the time you try and find the perfect answer to the question that you're trying to answer, you can actually find that that question is now irrelevant. And it's actually not the right question to be asking anymore. So this whole thing about flexibility, about collaboration that comes into it, but also 60-40 can actually be a very useful milestone as opposed to waiting until we've got the perfect answer. So I'll throw that one out there as a challenge to the academics too.
Thank you. There's a question down here as well.
Thanks, I'll change my question slightly like that last thing. You speak, and I fully agree that it'd be wonderful if we could work to 60-40, but the reality of most academic situations is that our externally imposed drivers are to produce journal papers that get lots of people reading and citing them for no particular purpose. And that's our drive, and that's our measure of esteem, that's our measure of, and you can't do that off a 60-40 piece of work. You've got to do that off, at the very least, something that's heading towards 90 or 95, because otherwise it doesn't get into the journals that we're told we need to put the journals into. So how can you see that we can change that system to encourage us to engage with getting good enough answers?
Part of the problem I know is outside the control of the university in terms of how the university is externally assessed, because it does make a difference to being able to attract both the right employees and the right students in. My personal opinion, which probably has nothing to do with any of those processes, is that there are actually different areas of expertise. In some areas you do need to have the purely theoretical stuff that creates the brilliant journal that is, finishes up with creating a Nobel Prize and all of this sort of stuff. And there should be some universities that focus on creating those people that can think about that stuff. But the vast majority of the world's problems actually needs to have part of the gap filled between those people working at that end of the scale and us in the real world, whether we're business, communities or whatever else. And most of us in the community don't actually have enough technical expertise to even know what the hell those guys running those papers are talking about. And therefore there is this whole world in between that I think a lot of universities and the sort of direction that ECU is going with some of the practical stuff that you're doing on site, we did a tour of here about a month or so ago, is actually around filling that sort of gap. That will add huge value to the world. How that then gets recognised in how ECU is measured, I don't know. But I think if you can start focusing on actually making a difference to the world, somehow or other some of those measurement systems are going to work out how to acknowledge that if everybody's coming to ECU because everybody says that that's the best place to go to get your questions answered and to learn how to deal with problems in the real world, somehow or other the system will adjust for that, because that's actually what the world needs a lot of at the moment that we're currently not getting.
Thank you. John?
It's probably an appropriate introduction to the observation I was going to make, and it was with regard to the way in which you develop the interactions between research capacity and industry. Recently I had the good fortune to go to a talk by my counterpart at the University of South Australia, soon to go to Macquarie University, a fellow called Saki Pretorius, whose background has been as director of the Australian Wine Research Institute, notwithstanding his South African background before that, but he had a good insight, I think, into the sorts of the way in which research can be applied to solve real practical problems. His his analysis of the way it might work at one end of the spectrum was identifying a team as being something like a relay team, where an individual runs fast with a baton, passes it to someone else, they pass it to someone else, and you eventually get to the end of the race. And I think the argument there was that might have been a more traditional approach, especially in universities, but a much more satisfying, successful, and I can't think of the third adjective, approach was to see it as more a soccer team, where people pass the ball backwards and forwards, building the what ultimately might be a successful move to score a goal. And so what are your insights into that sort of, those two models almost of the way it might have been, the way it could be, or the way it should be?
Linear processes I would normally put in the inefficient category, the relay race one, that, you know, once you've handed it over, you've just got to hope that the next person's going to be able to deal with it. Chances are they will run into problems. They will need to have more information based on what's happened in the step before. So I think it is more like the soccer team. But one of the things that underpins both of those stories is the rules of the game, or the objective, is clear to the whole team. And part of what's happening is people may talk about soccer teams at the moment, but they're sort of soccer teams with blindfolds on. That they've got some sense there's other players out there that they should be engaging with, but they can't quite see them and they can't work out how to, you know, collectively get the results that need to be achieved. So I think a soccer team is closer to the right answer, because to get to the end point, if the end point's the goal, it frequently will require multiple interactions with multiple players and a period of time before you can get there. And that also fits in with the whole 60-40 thing. You don't have a single player wanting to take it from one end of the field to the other. You've got to do your bit up to the best of where it makes sense, and then somebody else is actually in a better situation to be able to take it through, and you can then collectively get the better result.
Thank you. And sorry, if we might just have one last question from our debate. Being so patient, thank you.
I just wanted to perhaps revisit your discussions on innovation, and I guess what I'm interested in is perhaps how you talked about managing the risk and how you do actually go about managing that risk, because there must have been times, we've heard some success stories like a robotic robot, but there must be times perhaps when perhaps various parts of your department might have been up against the wall and you have to decide one way or the other, and some might have been successful and some might have been. I'm just wondering how you decide how you actually go about managing that risk, if you've got any comments you can share.
The biggest frustration that I have with risk management is that it actually has a very poor reputation as being something that policemen in head office or, you know, bureaucrats in state governments or whatever say, look, you've got to do this before you're allowed to do something. And very few people actually engage with it as part of the solution to the problem. One of the situations that we're trying to deal with Komatsu at the moment is that, as you can imagine, the sensors that go on these trucks regularly change. There's a lot of suppliers out there creating new things. So we're trying to work out what's the risk management process about when we put these new bits of fruit on the truck about how do we then change our procedures on site. And we're finding that the suppliers of the equipment just work in this whole artificial lab environment, and they, all the testing and everything they do, and they do the world's most brilliant QA/QC processes. But do they actually understand the risks of putting it in the environment, the risks that come about from the human interactions, and the fact that humans are not as perfect as the trucks are, and that they can have the world's best sensor, but if a human pushes the wrong button or whatever else, then it doesn't matter how good the sensor is. So we're actually having to move from sort of some qualitative risk processes. We're now having to really move heavily into the quantitative space. And it's making a lot of people uncomfortable. They've never been there. They don't trust the process. They don't actually understand how useful the outcomes are. I'm being able to win the argument to get people to engage with it because they had the problems first. I've been able to explain to them, look, risk management processes will allow you to work out how to find the solutions to the problem. But so few people teach risk management as a way of finding solutions to problems. To me, the only bad problem is the problem you don't know about. And if risk management helps you find more problems, you will find more solutions, you will finish up with a better result. That's as basic as what risk management is to me, so I use it all the time. But so few people adopt that as an attitude to it, and I think if you can get that framework around a risk management approach, especially when you get people engaged with it that have never been engaged with it before, that they understand from day one this is about finding solutions, it's not about keeping policemen happy. Then you can get a lot of stuff out of it. And sometimes it's hard work, sometimes you find stuff that's scary, but you eventually find solutions. And you've got to go in knowing that you will sometimes find things that you don't like to hear, but it's better to actually be aware of them.
Thank you. I'd like this afternoon to close the meeting by thanking Denise so very, very much for coming out to Cowan University. We appreciate that. I appreciate the openness, especially during our Q&A time, your honesty, the insights that you gave us as well, and for engaging so well. Thank you very, very much. If you want to